All right, so I'm gonna start over real quick, just kind of play along, and then I'll write everything out so it makes sense. So in example number 7, we're given f of x is x cubed minus 12x minus 5. From there, if we take f prime of x, we get 3x squared minus 12. If I take f double prime, another derivative, I get 6x. Okay? So now remember, f prime really tells us a couple of things. It tells us the critical points for f prime tell us min-max information. And then it also tells us whether it's increasing or decreasing. Now all this has to do with the original function f of x because we're taking the derivatives of f of x. Now what f double prime tells us, when we find the zeros or critical points of f double prime, that tells us when our rate of change is increasing or decreasing. And then it also tells us concavity. So it'll tell us the concavity, which is it could curl up or it could curl down. That's what it's going to tell us. And then at some point in time, we need to evaluate f of x at every critical point. X equals whatever we find for our critical points. So with this information, we could graph the function without plugging it in a calculator. Fairly easy, very accurately. Okay. So if I'm gonna take this apart and do it one thing at a time. So now I'm gonna work with f prime. I gotta find the zeros, right? So I'm gonna say f prime of x is equal to 3x squared minus 12. I want to find where that equals 0. And so by dividing both sides by 3, okay, I get x squared equals 4, or x equals plus or minus 2. Okay, does that make sense? Yeah. So we're going to do a first and second derivative test. So now I'm going to come here. Let me do one more page. So for my first derivative test, we're going to focus on f prime. Now remember, that's going to tell us increasing, decreasing, min or max. So I have a min or a max here. This is a min or a max, I don't know yet. And then I have a min or a max here. And then the other thing I want to know is if the function's increasing or decreasing. So remember that f prime, so let's go back and look at f prime, okay? So I need a point here that's less than -2. I need a point in the center of 2 and -2. 0 is very convenient. And then I need any point greater than 2. So if I come back to my f prime, and I come back here, I could say f of -1 million. That's all the way to the left of that thing, of the -2. So now if I plug in -1 million, which is a really big number, and I don't care what the answer is, if I square that and subtract 12, right, because that's what the original function is, it's 3x squared minus 12, this is going to be a really big positive number, right? And then when I subtract 12 from it, what will it be? It'll still be positive, right? So when I plug that in, there's a number to the left of -2 that's positive. Does that make sense?
Yes.
All right, so now I'm going to come back, and now we're going to plug in 0. So f of 0 is just 3 times 0 squared minus 12. It's just negative 12, right? Does that make sense? So that's negative. So I'm going to come in here for my first derivative test and say that's negative. Now when we go from positive to negative, this means the function is increasing and then it's decreasing. So it kind of looks like this. So we have a max at negative 2. Does that make sense? All right. So now this will probably be positive, but we want to double check. And, whoops, I went too fast. All right. So one last time for my f prime. This is f prime, by the way. Did I put the prime some notation? So this is f prime for all of these. Yeah, okay, I put all the notation there. So now I'm going to choose f prime of a really big number that's greater than 2, which gives me 3 times 1 million squared minus 12. Again, this is going to be really positive. This is going to be a really big positive number, even if I subtract 12 from it. Does that make sense? So what we're going to do then, that's positive. So now my function goes from decreasing to increasing. That's a min at 2. So that's all for f prime. Now I've got to go back and do the same exact process with f double prime, right? And that's going to tell me the rate of change or the rate of change, or the concavity up or down. So I'm going to plug in f double prime, find the 0, f double prime of x.
Wait, was this to find the concavity?
Yeah, which is equal to 6x, right? So I need to find the 0 of that. So the critical point for f double prime is 0. Now remember, we're supposed to see if it's not differentiable, and that occurs when the domain is restricted, but for both f prime and f double prime, it's all real numbers for the domain. So now, x equals 0, I'm going to come in here and we're going to do the second derivative test at 0. So I need to pick a number less than 0.
Negative 2.
Yeah, it doesn't matter, any number. Any negative number will work. So if I say f double prime of negative 2, 6 times negative 2 is negative 12. Right? So that tells me that it's negative from here to here. That means it's concave down, right? Concave down. That means it curls down. Now this might curl up. Probably will curl up. Well, we already know that it will. But we're going to do the math anyway. So now I need to take a number greater than 0. We'll do 1. How about that? And we're arbitrarily choosing any number greater than 0. I could choose 1, I could choose 1,000,000, whatever. But it's positive. Okay? That means concave up. Are you guys with me so far? Does that make sense? Now the last step in this process is we just want to go through and plug those critical points into f of x, right? So really what I need is we have negative 2, comma 0, comma 2. I need to find all those. So that's the last step, and then we can graph it. So f of x was what? Can somebody tell me what f of x was?
X cubed minus 12x minus 5.
So I need f of negative 2. So I've got negative 2 cubed minus 12 times negative 2 minus 5. This becomes negative 8. This becomes positive 24. Somebody do that on the calculator. Tell me what that is. Negative 13, what is that, 11? Is that what it is? Okay. So that means that the point negative 2 comma 11 is going to be on my graph. And we said, what did we say that was? A max, right? Alright, so now I need to do f of 0, which is 0 cubed minus 12 times 0 minus 5. So we've got, oh, it's not f prime, it's just f. I'm trying to hurry so it's not so. That means the point 0 comma negative 5 is also on the line. Then I need f of 2. Right? Which is 8 minus 24 minus 25, which is 21, isn't it?
Yeah.
Is it 21?
I got negative 21 though.
Yes, you're right. It's negative 21.
Negative 21.
Negative 21. So that means that the point 2 comma negative 21 occurs on our graph. Does that make sense?
Yeah.
Wait, is that the minimum then?
Yes.
And that's where the minimum is, right?
Yes.
Yeah.
So what is the 0, negative 5 point? Is that just a random point then? Or is
Huh?
that
Yeah,
What-
0, negative 5.
the, is 0, negative 5?
Well, it's not just random, it's the y-intercept, so it'll give us a little direction. So now if we're to graph this, right? We've got 3 points, 0 comma 5, 1, 2, 3, 4,
Negative
5.
5.
Was it negative 5? Actually, let's do this on the graphing calculator, okay guys? So let me clear this out. I'll show you a little trick here. We're going to clear this out. We'll go to stats. We'll go to 4. L1, comma, L2. Whoops. Comma, L2. Alright, there we go. There we go. So, what were our points? It was 0, comma, negative 5, right?
Negative 211.
Negative 2, and then 2. And so for negative 2, the corresponding one was 11, and then negative 21, right?
Yep.
Like that?
Yep. You have to push enter.
Is that right?
Yeah.
And so I'm going to set my window negative. Our x's were, actually our x's were really small. So I'm going to do negative 5 to 5. And our y values kind of jump around. So I'm going to say negative 25 to 25. And I got to turn my stats on, my plots on. So we'll just turn that one on. And let's just graph it. So I haven't plugged in my graph yet. So x cubed is a cubic, right? Was the leading coefficient positive or negative? Positive. So it comes in from the bottom, goes up and down like that, right?
Mine looks weird.
Well, yeah, it looks weird. We're not done.
No, compared to yours.
Yeah?
Yeah, I don't know why. Like, mine has another, like, I don't know.
So what did we say this point was? Didn't we say that was a max? Yeah? Now this was when f double prime was 0. So what's this?
Point of inflection.
This is a point of inflection, right? And so let's list why. So this was a max because this was when f prime was equal to 0. This was a point of inflection because f double prime of x was equal to 0. And then we said this was a min, and the reason for that is because f prime of x was equal to 0. Now, for the max, we're going to come in, and then we're going to go down, right? And we're coming up because f prime of x to the left was positive, and then to the right, f prime of x was negative, right? Now, because f double prime of x was positive to the left of the point of inflection, was it positive or negative? It was negative, wasn't it?
It was negative.
It was negative, right?
It's down.
So it's concave down, right? So we're going to have a graph that's going to kind of come up. It's going to kind of come up through here, curl down, and then at this point it will curl up because we said that f double prime of x was positive. So now it's going to start to curl this way, we have decreasing up until our minimum, and then it changes from that to increasing. Does that make sense? So that's kind of what the graph should look like. Does anybody have any questions where I got all that information from?
For some reason, my graph looks like it has one up there. I don't know what I did wrong.
I think you put it in positive, the -21.
Is that what it was?
Oh, yep.
All right, so now I'm going to erase all this. Do you guys understand what we're trying to do, right? All right, so we're going to erase this. Now let's plug in our function. If I say x cubed, was it minus 12x minus 5? And I hit graph. Does that make sense?
Yeah.
Now what I'd like for us to try to do, I want to show you, there's a quick easy way that you could do that. Let's say we had a really complicated f of x. Well, couldn't we take the derivative and graph that here? So what if I wanted to do the derivative of y1? So we could do like we did yesterday and hit second catalog, right? And then hit the log button, come down to end derive. And you can do the first derivative. We did the second derivative. But if I do this, then hit vars, then go over to function and choose y1. Then if I hit comma, x, and close it, now if I hit graph, it should graph 3x squared minus 12. Now we don't know we know because we used calculus to calculate it using the power rule, right? But that's what that is. And didn't we say the zeros for that were 2 and -2? Right? Isn't that right here?
Yep.
Okay. Now, if we wanted to, we could also take the derivative of the derivative, which is second derivative. So if I come in here, now I'm not sure. I'm scared. Maybe you guys could try it on your calculator. Try to do end derive of y2, x, and see if that will work. I don't know if it will, because I think you need a function. And I'll do it like we did yesterday. So if I hit second catalog, and I come in with, do you guys understand what I meant by that? Whoops, I gotta clear that out. I don't know if it'll do it or not. So if I come in here and I take the derivative, and then I take the derivative of the derivative, so we're doing like the double derivative like we did in yesterday's example. Oops, I gotta get up there. Now I've got to hit vars y1. Now if I come back, whoops, it didn't want to finish it for me. Hold on, getting excited. Comma, x, close the derivative. That's that one. Comma, x. And I think if I hit graph, now I'll graph 6x, which should go through the origin with a slope of 6. Now we know that because we did calculus. But just imagine if I gave you a function, right? That was easy to take the derivative, but just imagine if I gave you a function of like log base 3 of x squared all over e raised to the 2x. That would be kind of hard, but you still need to find the critical points. You still need to figure out when it's increasing or decreasing. Obviously, if you have the graph, you can figure that out. But how would you pinpoint exactly where the point of inflection occurs? Where the second derivative is 0, right?
Oh yes, I was.
So if we look at our graph, so this is what I was trying to show you. We can see it graphically too. It takes a little bit of practice though. Our critical points were 2 and -2 because that's where f prime, we're almost done guys, that's where f prime was equal to 0, right?
Yes.
All right, then the other thing is the concavity occurred based on the second derivative, which is f double prime. And its 0 was at 0. So because this 0 is here, that means that my point of flexion on the line is here. So this corresponds to the max, the local max. This corresponds to the min, right? Now, if I follow this graph, it's positive all the way up to here. That means my function is increasing. From here to here, it's negative. That means that my red function, let me do that in red, increasing to here, right?
Yes.
Then from here to here, all this right here is decreasing. So my function, f of x, should be decreasing. Then from here to here, this value here is positive. This is my first derivative. So that means this function should be increasing. F of x should be increasing. Concavity is based on the curling, right? So this curls down. Why? Because the second derivative is negative all the way up to this point. Well, that corresponds to my point of inflection, right? And then it's positive from this point, which means we're going to have concave up. Well, that looks confusing when you see it all drawn out like that. Does anybody have any questions?
I just need to stare at it for a little.
But that's really cool. Did that work if you did like the n derive of y2? That would be even quicker.